Hello to everyone and welcome to part 4 of this video series. Now for those who haven't checked the part 1, 2 and 3 out, I'm going to put a link in the description box and in the comment section and even as a card above here so that you can click on that and get all the videos under differential equation. So in this video we're going to be looking at 2017 and this is question 3 of 2017 and it's a proof. The question says that using the substitution xy, so we have been given our substitution xy equals to v. Then we are going to call this equation 1. They said where v is a function of x, transform the differential equation. This we have been given our differential equation, so our differential equation is x squared dy all over dx plus xy equals to y cubed. Now this is our differential equation. We're going to call it equation star. Then into a differential equation in v and x, so that is the first thing we need to do. We need to transform this differential equation into a differential equation in terms of v and x only, and hence show that for y equals to x equals to 1, y squared is 3x all over 2 plus x cubed. So actually this is a proof that we're going to do, and we see that to solve this, we see that from equation 1, we see that when we differentiate this equation 1 with respect to x, then we're going to have x dy all over dx plus, if we keep now our y constant and we differentiate x, we're going to have 1 equals to, now the derivative of v with respect to x will simply be dv all over dx. So now looking at our differential equation, we have x squared dy dx plus xy, and here we have x dy dx plus y equals to dv all over dx. So if we call this our equation 2, and we say equation 2 times equation times x, so if we multiply this our equation 2 times x, we're going to have x squared dy all over dx plus xy equals to x dv all over dx. So dv all over dx. So now we are going to name this our equation 3 for a reason. Now if we look at this very well, we notice that the left hand side is exactly the same as that in our equation star, which was the original equation that was given to us. So instead of writing x squared dy dx plus xy, we're simply going to replace it with x dv all over dx, since we want to express our variables in terms of x and v only. So we're going to have now, so putting equation 3, so equation 3 in equation star, therefore we're going to have x dv all over dx to be equal to y cubed. So we see we're gradually simplifying our function, but we notice that the substitution from equation 1, it says that our y is simply x all over, our y is simply v all over x. So that is our y. So we can call this equation 1 star, right? So y is v all over x. Therefore, if we substitute it in this our equation, if we substitute it in our equation double star, then we're going to have x dv all over dx to be equals to, so we're going to have v cubed all over x cubed, so that we are going to have x. From here, if we want to rearrange our function, we might decide to cross multiply. So if we cross multiply, we're going to have x to the power 4 dv to be equals to dx v cubed. So we're going to decide to divide all through by by dv all over dx. So if we divide all through by dv dx, dv dx, then we're simply going to have here, so we're going to have x to the power 4 divided by dx to be equals to v cube divided by dv. So now we're going to reciprocate, and whatever we do on the right hand side, we're going to do it on the left hand side. So we're going to reciprocate our function. Now reciprocating our function, we're going to have, finally we're going to have dx all over x to the power 4 to be equals to dv all over v cube. So okay, now to differentiate this or to integrate this function, we're going to have the integral of x to the minus 4 can be written as negative 1/3 x to the minus 3 plus our constant k to be equals to, now the integral of this can be written as negative a half v to the minus 2 plus our constant, okay, well, minus 2. We have already mentioned the constant on the left hand side, so there's no need. So basically we have our function in this form. So this is actually the solution of our function of the first part of the differential equation. This is the solution of the first part of it. Now the second part is that given that y is equals to x, which is equals to 1, and that v is xy. So these are the two conditions that we have. So from here it implies that our v is 1. So our v is 1. Our v being 1 means that 1 on 3, x being 1 will just give us 1 plus our k to be equals to minus a half. Therefore we're going to have our k to be equal to 1/3 minus a half. So if we calculate that very well, we're going to see that our k will be minus 1 all over 6. So that's our k. Now if we substitute our value of k back here and we make our y squared subject, we substitute our value of k and v in this function and we make our y squared subject. So here we're going to have so this will simply be, we have negative v, so we can rewrite it as we can rewrite this as negative 1 all over 3x cubed, now minus 1 all over 6 to give us negative 1 all over 2x squared y squared. Now x squared y squared, because our v is xy. Therefore, if I decide to multiply all through by x cubed y squared, let me say 6x cubed y squared, so that I can linearize it. So I'm going to have minus 6x cubed y squared divided by 3x cubed minus 6x cubed y squared divided by 6 to give us minus 6x cubed y squared divided by 2x squared y squared. So clearly we see here that this is going to cancel, so we'll be left with that, and 2 here will give us 3, so we'll be left with 3 there. 6 is going to cancel and the cube is going to cancel, so we'll be left with 2 there. Therefore we're simply going to have negative 2 y squared minus x cubed y squared to give us minus 3x. So if we factor out our y squared, in fact we see that negative is constant, minus is constant all through, so it becomes positive. So when we factor out our y squared, we're going to have x squared plus 2 to be equals to 3x. Therefore our y squared will simply be 3x all over x squared plus 2. So that is the proof, and that is all for this video. So thank you very much for watching till the end. If you want more of this kind of videos, please just subscribe to the channel. If the video was helpful in one way or the other, give me a like, and see you guys in the next video.